Hey, it's Mr. K, Physics 30, Unit C Review, Question 6. Okay, we have white light. When white light from the sun strikes a flint glass bead, the white light is separated into its component colors, called dispersion, two of which are illustrated in the diagram below. So we have the dispersion here. We can see the colors being separated. Now I've gone back. You can kind of see this white line represented here, not really. But if that white light had gone straight through without refracting, it would have gone essentially straight here. And then what we know is that violet refracts more than red. So we've got violet refracting more. If we trace it through, it connects with the violet. We have red refracting less. So that's the key idea here when we're dealing with different colors, is that violet refracts more than red. Okay, now which of the following statements, I'm going to walk through how I cancel each of these. So just starting here with C and D. Because violet reflects more, because red light reflects less. I know we're not talking about reflection, we're talking about refraction. So the first thing I did was I canceled out the points about reflection. Okay, then that brought me up to here. I have these two options. Looking at the first one. Violet light because red light refracts more. Now, I knew that wasn't true. So I could choose B just based off of cancellation. But looking here, I'd also like to talk about this index of refraction piece. The index of refraction of red light in flint glass is less than violet because red light refracts less. Now, in this case, what I'd like to think about is I've got that white light coming in. Okay, so it's coming in. Think about the two wheels of the analogy hitting it. Now in the glass bead, this one slows down. The other one essentially keeps going and it turns the vehicle. So what I'm going to have is, I'm going to have these two beams not going straight, but separating. I know that violet is going to bend more than red. Now in terms of what that means for us, now we know that air is fast and we know that the bead is slow. We know this because of their comparative optical densities. We know this because space and air are basically 1.00 index. But going back to this point, in order for violet to have bent more, one way we can explain that is we can say that violet experiences a higher index of refraction. So we know that slow means high index of refraction. So if we're going even slower, like if this hits a different kind of mud to slow down your vehicle and really turn your car, that must mean that that index is higher. Now, I'm not crazy about this, but this is one way of looking at it. Secondly, with the red, we could say comparatively, the N is lower. In terms of the speeds, we could say that the V is lower for the speed compared to the red. There's all sorts of different comparisons we can make, but this one's the most common one where we're talking about the index of refraction. So then if we say the index of refraction for red light is less, well, I can agree with that. It was not as affected by the transition. Okay, thanks for tuning in.